Hello, my name is Boris Platov, and this is Center for Advanced Training, Quality Management and Marketing, Institute of Geology and Petroleum Technologies, Kazan Federal University. Another important question is the velocity modeling. The thing is, once you trace the horizons, they are still in time domain, and we cannot find out the actual place to drill. We cannot find out the actual depths to drill, even if you get this kind of anticline. So what to do? To force your data to be transferred from time into depth domain, we need to use velocity. There can be quite a lot of different velocity models. For example, if we start with a pretty simple velocity model, it can be homogeneous. That means your velocity is not changing at all. This type of model can be used in the very beginning of your interpretation, once you don't get too much information. The more complicated case is the layered homogeneous model. In this case, you can divide your succession onto certain layers, and each layer gonna take its own velocity, which is not changing inside the layer. That is a simple model, but still it's more complicated than just a homogeneous model. Continuous model. In this case, your velocity is changing gradually inside a certain interval, inside your velocity. For example, we know that velocity is increasing with the depth, and we can force our velocity model to increase its velocity with the depth. And the most complicated case is the layered continuous velocity model. In this case, we are dividing the whole succession onto certain intervals, certain layers, and within each interval, our velocity is changing. During the interpretation, the interpreter can use several different velocity models. For example, on the first step, we can apply the simple velocity model, and then look how our structural map looks like. If we are not succeed with this velocity model, we can try another one, and then another one. And by each step, we are improving our velocity model. And each step is called the iteration. So the construction of the velocity model is then the iterational process. But how to get velocity? Actually, we get a couple of data spots. We get seismic data, which is in time, and we get well logging data, which is in depth. We can connect them by using seismic to well tie. And this connection can give us the information about the velocity in every well. And that's the way of obtaining the velocity model. The next question is how to construct structural maps. And I'm going to present you one of the ways of creating this type of structural maps. The first thing is doing seismic to well tie. Of course, first we have to know which horizons we are going to construct. The second step is horizon tracing, like finding which horizons we want to trace and create the T0 maps or isochrone maps. Then we can subtract the top isochrone map from the base isochrone map to obtain delta T. That's the thickness between these two layers, but the thickness is in time domain. Then we can look at a certain well. For example, in this well, we know the time thickness between the top layer and the bottom layer. For example, in this well, we know the time thickness between this level and that level. And that's how we can obtain this distance in time domain. But then, for the same well, from the log, we know that this reflection corresponds to that well top, and this reflection corresponds to that well top. And we can find out the distance between the well tops. That's how we can find the thickness in depth domain. Afterwards, we can calculate velocity. We're simply taking this distance in time domain for this well, and then the same distance in depth domain for this well. And we are obtaining the interval velocity for that interval in this particular well. Then we can try to do the same procedure for all of the wells in your region. In this case, you're going to obtain quite a lot of the points with interval velocity for the particular interval. Then we are constructing the velocity map. And that's going to be the interval velocity map. That means this velocity corresponds to the interval between the top horizon and the bottom horizon. And then we are doing a couple of steps. First of all, we are taking this interval velocity and we multiply this interval velocity by the thickness in time domain of the same interval. And that's how you can obtain the thickness which is going to be in depth domain. And once you obtain the thickness in depth domain, you can use this thickness to investigate the geometry of the bottom horizon. That means if you get a structural map of the top horizon, you can plus here the thickness to obtain the geometry of the bottom horizon. And then continue with that horizon. So we are taking now this horizon, taking this time thickness to the next horizon, obtaining the velocity model for that interval, multiplying the time thickness by the velocity, obtaining the thickness in depth domain, plus here thickness in depth domain to investigate the map of the next horizon. And that's how we can obtain the structural maps of all of the horizons from the very top to the very bottom. How to get the map of the top horizon? Actually, in the simplest case, we can use the sea level as a top horizon. So we know that depth of this sea level is 0, and we know that time of this sea level is 0 as well. In the end of the day, we can obtain the structural maps of all of the horizons that we need. And that's the aim of the structural interpretation of the seismic data.